Hey there, gang. In this video, we'll continue talking about how we can represent ratios with graphs. So this first blank up here, that's what we would put in that blank. Ratios can be displayed on a graph or coordinate plane. Okay, so what we're going to practice here on the front side is you've been given a graph here of number of miles traveled, okay, over a specific period of time in hours, and each of these ordered pairs, okay, represents an amount of hours and an amount of miles. So what we're going to start out doing is just write out these ordered pairs in this chart here. In this x comma y format. The first number would be the x coordinate, so the amount of time, and the second number would be the y coordinate, so the amount of miles. So our first point here is 1 comma 50, and then we have 2 100, 3 150, 4 200, 5 250, 6 300, 7 350, 8 400, and 9 450. Okay, so those are the 9 ordered pairs represented on this graph. Now what we're going to do is we're going to transfer these ordered pairs into this ratio table below. So again, the x coordinate, the first number in each ordered pair, represents the number of hours. So we go from 1 hour to 9 hours. So this column here is going to be 1 through 9. And then the next column is the number of miles, and the number of miles is represented by the y-coordinate since it's on the y-axis of this graph. So we start at 50, and then we go up through 450, increasing by 50 each time. So 100, 150, etc. Okay, so this is what our ratio table looks like down below. And now, just like in the last lesson, your job is to figure out what is the rule to get from the number of hours to the number of miles. Okay, what are we doing to this number each time to get this number? Well, to get from 1 to 50, you know you can multiply by 50. And so ask yourself, does that rule apply to get from 2 to 100? 2 times 50 is 100. 3 times 50 is 150. And that pattern actually is true the entire way through. So the rule each time is we take the number of hours times 50 to get the number of miles. Okay, so if I were to replace the number of hours with my variable h and the number of miles with my variable m, the equation might look like this. The number of miles m is equal to the number of hours h times 50, or again we can write that as m equals 50h would be our equation. And a verbal description for this, remember to use a complete sentence. This just means that every hour 50 miles are traveled. Okay, now let's flip over to the back side and look at a couple more problems like this. Okay, for example 1, this time I haven't given you the graph. I've instead given you the equation. Okay, m equals 5 times d. And so our job now is to come up with the graph, the ordered pairs, the ratio table, and the verbal description based only on this equation. It says a bike rider graphs his training for the week. Okay, so we know that d is the number of days and m is the number of miles. Okay, so what we're going to do is we're just going to start out with our ratio table, and we're going to start out by filling in these numbers of days down here below. So 1 day, 2 day, 3 days, etc. And we can go all the way through 7 days on this table. Okay, now the equation, what the equation tells us is it tells us the rule. Okay, it says m, the number of miles, is always equal to the number of days, d, times 5. Okay, m equals 5 times d. So that means every single time to get our number of miles, we're going to take the number of days times 5. So 1 times 5, 2 times 5, 3 times 5, 4 times 5, etc. Well, 1 times 5 would be 5, 2 times 5 would be 10, 3 times 5 would be 15, and so we'll just keep on going by 5s through our miles column. So that means our ordered pairs are going to be the following. 1, 5 would be our first ordered pair. 2, 10. 3, 15. And then 4, 20, etc. Okay, so now I want to plot these 7 ordered pairs on the coordinate plane. So 1, 5, here's my origin. Here's 0, 0. 1, 5 would be right 1 and up 5. Notice 5 is marked right here. So there's 1, 5. 2, 10 would be right 2 and then up to 10. So here. 3, 15. 4, 20. 5, 25. 6:30, and 7:35. So that is what the graph of this data would look like. Verbal description for this just means that the bike rider rides 5 miles each day. Okay, for the last problem that says a factory is able to manufacture a certain number of parts each hour, this time I've given you the graph and I've given you part of the ratio table. What I'd like you to do is I'd like you to pause the video and then try filling out the rest of your ratio table as well as your ordered pairs, your equation, and your verbal description. Once you have all that filled out, please click play to check your answer. Okay, so go ahead and look at your ratio table and your ordered pairs. Now for this one, your ordered pairs may be slightly off of mine. Okay, so you have to do a little bit of estimating for some of these ordered pairs. So for instance, this first ordered pair, it's at 1 and it's just above 10. So I went ahead and marked that at 112. The next one I marked at 336, 448, 560, and then 896. Okay, the reason I did these numbers here is because if we put those in the ratio table, then we can easily see a pattern of multiplying by 12 each time. Okay, you multiply the number of hours by 12 to get the number of parts. If you had maybe a 13 instead of a 12 here, that pattern might not work for you, but if you adjust those numbers to these numbers here, you can see it's a nice pattern of multiplying by 12. So that means the equation is going to be the number of hours times 12 is equal to the number of parts. So P equals H times 12. Or we would commonly write that as P equals 12H for the equation. And the verbal description, that just means that the factory makes 12 parts each hour. Okay, as always, if you have any questions over this video, be sure to jot those down and ask those the next time you see me. And until then, have a nice day. You're all wonderful people. Take care.